Welcome everyone to this lightning talk about everyone's favorite hype topic, the foundation models, hype and best practice. So today I'll try to give a bit of an introduction into what foundation models in forecasting specifically are, how they look like, what they do, concepts like weights, data, model code, APIs, how to manage them, how to use them, best practices, best practice recommendations, and of course also how to use them as part of the scikit-learn compatible ecosystem around skTime. Now, whenever you have questions, please feel free to use the chat. And this lightning talk is connected to the skTime community and also to a full forecasting course on Maven with a number of topics that I will also briefly talk about at the end. You can, of course, join. So, any questions before we start? Just to mention it again for people who just joined, we are recording this presentation. So, what is a foundation model? Right? So you also sometimes hear foundational model, foundation model, and this term describes pre-trained models that are pre-trained with the intention that they perform on a wider range of data. And forecasting foundation models are such pre-trained models that are pre-trained to perform well on the task of union multivariate forecasting and different variants thereof. These typically use the transformer-based deep learning architecture or other advanced deep learning architectures. So how they're typically used is as follows. There's a provider, sometimes a company or a research group. They have access to a large amount of data, which can be real world or synthetic or a combination thereof, for instance, through augmentation. This provider of the foundation model then trains the model on a large amount of data that results in trained model weights. For a torch model, these weights and the code to run inference with that model, typically, not always, are put online on a marketplace. Sometimes not, sometimes it's not even provided to the user. I will explain that. And then the user uses the forecasts with that set of weights on their data. So I've said, okay, the weights are in a marketplace, but they could also be behind an API. So whether the user can actually download and inspect the weights or not, that already differs by model. So typically, not always, as said, the weights can be obtained from, for instance, Hugging Face or Replicate or an equivalent weight repository. So that's a semi-open model. Or there's the so-called gated model, where only through an interface, through an API, typically also accessible only through an authenticated and paid subscription, you can use the model in this way. The batches are pre-trained. The pre-training happens typically on large batches across various domains. So the pre-training is also representative across domains and typically not accessible to the end user. Now, this entire idea of pre-training large deep learning models, this is coming originally from the language space, so language models, language prompting, and generative language tasks. More recently, the idea has been translated to sequences of numbers, so to forecasting, and there it's typically univariate or multivariate forecasting. Right, this is being applied. Other time series tasks, they may be supported. So common tasks are here, for instance, anomaly detection or time series classification, but they tend to be rarer. Forecasting among time series tasks is quite popular. So to just also establish a connection to so-called global forecasting here, there's a close relation, if you've heard about it. So global forecasting is you train your model on a bunch of time series, and this pre-trained model then is used on different time series. So for instance, if you are in sales context, you could train the model on sales from one shop, and then, for instance, make forecast on another shop, or train it on 1,000 and forecast one other, or you pre-train the model in an energy context on energy supply and demand time series from multiple locations, 50,000 maybe, and then apply it to a new location. Now, that's the principle of global forecasting, pre-training a model on some series. Now, in foundation models, and that is not an intrinsic property of foundation models, but it's simply how they are distributed. In foundation models, this global training is typically done by the provider. So the user doesn't see it, the user doesn't even have the data. And the pre-trained weights is what gets distributed. So it gets downloaded or it's distributed through a gated API where then the user can have access to the foundation model. And in foundation models, the global interface is through these weights. So you cannot or aren't even expected to train the model from scratch, which can be an advantage or a disadvantage depending on your use case. And in classical global forecasting, the user has an interface to train the model on their own data, which is often small or mid-size, and it's maybe not across domains. So both are instances of global forecasting. With the global forecasting, in the case of foundation models, the pre-training is typically not done by you. So the full pre-training step. Then there are a few other terms that you often hear. Zero shot, few shot, and fine tuning. These are also related to global forecasting. So zero shot means if you apply the model on your time series for forecasting, then you do not actually do training or fitting. You just ingest the context and it continues the time series. So there's no extra fitting involved. Few shot is you provide the model with examples, but there's also no substantial change to the core model weights. So you provide the model with some examples to have a few better guesses about your domain and then makes the forecasts. Whereas fine tuning is the process to adapt the core model weights, for instance, through lowering update. But already you start with a set of pre-trained weights, and then these core weights get updated with an additional corpus of your own data. So to see the entire flow diagram of what happens here for a foundation model. So we have, what do we have? We have the data it is originally trained on. That's here in the orange box on the top left. So you have a large training corpus where the model gets trained. So then you have a set of pre-trained weights. And these, so in the semi-open model, they get disseminated, for instance, through model hubs like Hugging Face, Kaggle, Replicate. For models that can be fine-tuned, and that is not all of the models, the user can additionally fine-tune the foundation model, the pre-trained model on their own data. So it's different from few shot, in that few shot uses these examples as a context, whereas in fine-tuning, you carry out an operation on the core weights or an update to the core weights. And then finally use it for forecasting. And if you are familiar with the LLM space, well, in the LLM space, you have, well, whatever you think about ChatGPT or Grok or equivalent solutions, you put some text in, it's the prompt or the context, and then it produces an output. And context and output in the case of time series is the historical time series data and the forecast that you're trying to make here. Otherwise, the flow chart is very similar to what actually happens in the large language space. And as you already see here, well, now you have to handle the weights. If you are using a semi-open foundation model where you actually have to manage the weights, and then there's code around the weights for inference. Even if you don't fine-tune, right, you have this interplay between your own data that you pass as a context, the weights that you have to get from somewhere, and for instance, the serialization of the model. In the gated model, so the orange part is secret. The provider does that. You typically don't see this unless you build your own foundation model. The green part is what you interact with in the foundation models that are partially open, so open from the stage where you can get the weights from Hugging Face. And if you're looking at the gated model, then you cannot see any of this. All you see is this very last bit, context and output, and the rest is gated. So it's hidden, right? Therefore gated behind a commercial paid API. So the weights are then behind the paywall, and all you can do is the actual act of producing a forecast or an output. Now, there's different degrees of openness here in the entire system as well. And I'll try to explain how it looks like for the 2024-2025 trend. So different parts and different pieces of information, so different parts of the model, different pieces of information can be or may or are not open in the sense of that you can obtain it, download it, control it, or have it in, for instance, in your own on-premise or air-gapped system as you wish. So whether the model weights, I think the main distinction is really the model weights. Are these available on a platform like Hugging Face or not? And there's a difference between the gated and the semi-open model. And of course, for the gated providers, that's how they make money. Hence, there is a lot of propaganda. They say, well, it's the best thing since sliced bread, but you have to be aware for many of these providers, that's actually the core business model. That's how they generate revenue. That's how they make money. And therefore, they want as many people as possible to subscribe to the gated models. Inference code, so that's the code which uses the weights to make inference. So predict the future from the past in the case of forecasting. That also varies, but if the model weights are available, then the inference code is also available. So it's either both are open or not typically. The model architecture you can inspect, right? For the non-gated models, you see the weights. If you see the inference code, you also understand mostly how the model looks like. Training code and training data are typically not available. So even for the models that say, we are open source, this part is typically not available, not inspectable. There are exceptions, for instance, in the language model space, there's some providers that even open source their training code. But this so interestingly, this also could be strategically placed. So for instance, DeepSeek, you might have heard about this in the language model space. It might actually be a strategic release, for instance, to undermine competitive advantage of in a geopolitical context. The training data, that's again something you need. That's again, if you want to build your own foundation model, you would need to train it. Usually not available. Sometimes there are, of course, data set collections, but it's not always the same thing that's trained on. The data collection methodology, so how was it collected, might be vague, and it might actually be obtained, especially for language models, in violation of intellectual property, so scraping the internet, for instance. Or, well, if a company is also a service supplier for businesses that have time series and they have the cloud, and you give them your time series data, well, maybe their foundation models are trained on your data if you sign something in their terms and conditions. So there's a question about are these transformer-based models? Yes, in the sense of most of, but not necessarily. So most of the foundation models follow some transformer-based architectural core. So evaluation benchmarks usually open, but again, I'm being a little bit sarcastic here, but there's certainly a kernel of truth to it that for every foundation model, there exists a benchmark where this specific foundation model is first in the benchmark, obviously. So to be aware, if you have foundation models, what's the different categories? There's 3 different categories. So degrees of openness. Mainly, is it gated or semi-open? But which parts of it? So there's also graduations there. What is the learning task? So if it says time series foundation model, it could be forecasting, it could be something else, time series classification, anomaly detection, some of them are even multimodal. And which capabilities does it have? So zero shot, few shot, fine tuning. These are capabilities with respect to the pre-training part. So looking at time series foundation models in practice, users should be aware of three dimensions. So there's, of course, the methodological abstraction. Is it forecasting? Is it univariate, multivariate, hierarchical, probabilistic? Is it actually also, if you have, for instance, a few shot, is it global few shot or is it local few shot? Then software, so the engineering aspects, which libraries, dependencies, software dependencies in Python and beyond do you need? Handling the weights, handling the weight repositories like Hugging Face, for instance, and or APIs. So the APIs can be APIs to weight repositories, or they can be APIs, for instance, to gated models if you want to use them. There's pros and cons, obviously. And then there's the commercial and legal side. Right? So you have phenomena like customer login, for instance, as I've said. Gated model providers, they do have a vested interest in recruiting users of the gated models and also keeping them. So if there's, for instance, an equivalent open solution that people can use that's not in the interest of a gated provider, that users can switch easily. Contracts, contractuals, and of course licenses if you talk about contracts. We'll talk about all three aspects in very high-level detail today. Of course, if you want to know more, you can always join our course and the exercise sessions and the one-to-one mentoring there. So, methodological. Methodological, purely scientific, there's first, if you see LinkedIn posts, social media, there's lots of propaganda there. So many leaderboards. My model is always the first on the leaderboard that I present. The pre-training batch is also secret. So in theory, by accident or by design, it could have contained popular benchmark data sets. So of course, if you pre-train your model on data, you still have the problem like in classical machine learning. If you train your model on the data, it will the same data that you use it to test it on, then it will perform well. In the extreme case, it just could have learned the data by heart. So that's often not known because the provider only hand you the weights. You do not know what it is trained on. And sometimes there are assurances in the paper, oh, it was not trained on this public data set, but there's no way to know. So you have to test it also yourself, but you have to be aware that there is, in principle, you don't have 100% safety, security in the sense of certainty. That's the word I was looking for. You don't have 100% certainty that the test data wasn't in the training set. Then there's also influencer campaigns, often paid by these gated providers, which aim at, of course, revenue generation and customer login. Whether they hold up to scrutiny, but I think that's not the important question here. The important question is, does the model work for you? So it's difficult to know, and every week, every month, there is a new foundation model. Some of them may actually be great. Some of them may be great, but only for a specific type of data. But the important question, in my opinion, is, does it actually work on your use case? And how good does it work? How well does it work on your use case? And for that, you need to test it. Don't believe or consider at least unproven claims about the goodness of a specific model. Make sure you have a reliable way to test models on your own use cases. And that means also a reliable framework for benchmarking and evaluation. So, okay, there's a question, what's the difference between SK time transformers and deep learning transformers? I'm going to go a bit of a detour because anyway, we went through this topic. So it's a different concept and it's an overloaded term. So actually the origin for transformers is scikit-learn, and there it simply was a concept for a data pre-processing step. So the use of the term transformer in scikit-learn as data pre-processing and post-processing step, it predates the attention is all you need transformer from the deep learning domain. And independently, right, this is convergent etymology. The term transformer is used for both, but of course the deep learning transformer term became so popular. So often people working on scikit-learn's SK-time, they say transformation instead of transformer just to make it distinguishable. But of course the word transformer, because it's how originally the classes in scikit-learn were called transformer, it still sticks and it is still how the classes are called. All right. So legal, I'll gloss over it. So as costs, legal, data protection, you need to be aware of the high level things to check, but also internally your decision makers need to be aware of these things. Then there's handling of software artifacts if you think about engineering aspects. And here, that's also an interesting state of affairs. Perhaps it will change over the next years, but currently it is, if you want to use these semi-open foundation models, the model code is not easily installable. So, okay, so most of these, they do not have proper package releases. So they're available as research repositories, but if you actually try to install them like normal Python packages, you run into a lot of trouble. And especially if you want to just run a simple benchmark, 3 foundation models, or you want to try it on your own data, if you haven't tried it, you probably can't imagine the difficulties you will run into. So you have heavily and conflicted dependency sets, highly inconsistent APIs, and often, even with these packages that say, okay, it's open, there's always an upsell, or often an upsell, to a commercial solution on top, which says, oh, we will take care of all that installation or deployment for you. So of course you have now tried to install a package here, but it's actually also available as part of our super nice next generation whatever platform, and which may or may not be true. But maybe you have to sign a contract, and maybe the platform is not interoperable with the other platform that has the other foundation model. So that might get you into further engineering problems if you actually try to compare 3 foundation models, because it forces you to commit to one from an engineering perspective. Now, so SK-time. So SK-time is openly governed. We're offering this course also as a means to help fund development and the nonprofit mission that we have. And we are also co-governed by our users. So we're trying to provide access to algorithms, including the foundation models, under a consistent API. And we try to maximize the pattern of user in control, user controlled AI ecosystem and software ecosystem. So we're also trying to architect it in a way that you have control of what you're deploying there, what you're using there, and it's also in a unified interface. For instance, if you notice, okay, this foundation model doesn't work for you, it should be just a change of a few lines of code to use the other forecaster foundation model. Or, well, you can compare it to a naive forecaster or a statistical and machine learning method, and it's just a matter of switching out here the interface. If you've, for instance, seen scikit-learn, or if you've seen the LangChain package, it is the same principle. There's also a wish list of foundation models, so you can even contribute and join if there's a foundation model that you think is missing. And I know, for instance, in the last 2 months, there have been a couple, and I haven't put them in this table. For instance, Toto is a new one, but it's already in this issue 6177. You can also add your wish list of foundation models that you want to see, or maybe that you need for your internal use case. There's even instructions on how to add them either to the public code base, or you can add these models in your private code base. That is maximum user control. You don't need to contribute it to the public code base, so you can later use it. We also have private and closed source extension patterns that's requested a lot by our users, because maybe your secret sauce is in there, so you don't want to contribute it to the public package. No. And why is this important? Why is this important for also users in general who want to stay in control? For instance, two popular foundation models, and they're not bad, but just look at the two APIs, and they're not, I mean, they're similar, but then you have to do all this remapping if you want to have them in a really exchangeable interface. All right, so tiny time mixer or Moira, and you see the places where you put the arguments in, where you specify your model and how you use them, deploy them and deploy them or configure them are different. You also need to manage model code dependencies. So even if you build your own framework, this is something you have to do. That's a big, of course, now it's a little bit of advertising for SK Time. It's not a paid solution. It's open source permissive license. So, but if you do it without, you have the same problems. You have to manage the model code. You have to manage the dependencies of the model code and the weights. They also come potentially with their own dependencies. You have to manage the weights as artifacts. So here, in a conceptual way, right, you have the foundation model, the framework layer, the weights, and the model code. Little bit of SK time code. This is how it looks like. So if you have seen scikit-learn before, then it's the same if you've seen SK time before. There is no substantial difference in how you use foundation models or other forecasting models to normal models. So the time mixer, so originally it's available in this IBM repository, which has also undergone a number of changes. And I think initially it wasn't even a Python package that you could install. So some users who wanted to use that foundation model, they contributed it then to our code base. So it's compatible then with the building block interface that we have. And it just looks like this. So you fit it. This is, you pass the context in fit, and then you call predict. If you've seen scikit-learn, it is very much the same principle here. And oh, well, okay. This forecast isn't very good, but now there's some tricks to it. For instance, few-shot learning that we have seen before. You can also do detrending. But before we go to that, right, how do we manage these artifacts that we have seen, the framework layer, the model, and the weights? So the weights are in the model path parameter. That can be a Hugging Face. So Hugging Face is a weights repository. It can be a compatible model string. So then it uses the Hugging Face backend. So it gets it from the weights a cloud repository, which is open source, or it can be a local path in the folder. If you want to run it on premise, then it gets it from there. Of course, you have to set it then up. And for this one, even full tuning from pristine is even suggested. And of course, if you don't have that amount of data, then maybe you don't want to train your own foundation model. Fine tuning is also supported. For that, you have to provide additional arguments, and then you get fine tuning on a single time series or a batch. And this is again showcasing the idea. It is doing that on your own data, but under the same interface as every other SK time model here. So familiarity of interface also makes it exchangeable in a sense. You can also provide these models to a benchmark or build pipelines with them. And lo and behold, well, it's slightly better. It's a toy data set though, but same principle works to try it on your own data set. Another example, times FM forecaster. You have to pass a context length and horizon length. The code is basically the same. So any foundation model in principle works like this. Now, another engineering problem that you will encounter with the foundation models, if you go down the semi-open path, is you have to manage dependencies. And these foundation models come with their own dependencies in the sense of Python. There's a number of repositories which are really research grade. So even the big players, the multinationals, they publish repositories where you have pinned dependencies, narrow dependencies, even conflicting dependencies. Yeah, so we have a few examples where, for instance, the model works only on something like only Python 3.10 on Linux, nowhere else. So you have a really specific dependency set. So what we have done is we have forked some of these really hard to install packages. We have stripped out the unnecessary dependencies, and we also ensure stability via deprecation management. And so this is now a non-SK time interesting fact to know. Often for these foundation models, there isn't a trustworthy PyPI release which is available. So it means they're only available through repositories, but then, some random party, malicious or not, it's often hard to tell, they upload a package to PyPI with the same name as the foundation model. And they might actually be working packages, right? So they might actually doing the same thing that SK-time is doing. So they strip out the dependencies and make the code nice, but they're not official packages. Right? They're not necessarily provided by the original provider of the foundation models. So if you don't know that, you have to be aware it's potentially supply chain attacks is a possibility if these people are completely anonymous. Or well, you just if there isn't a supply chain risk in there, you may want to consider, for instance, if you still want to use it, mirror it maybe locally to avoid, for instance, or pin it to get suddenly unexpected changes to the code. Then there's also the question of license, right? So license stability or license instability. The license might change over time for the commercial models. So a permissive license might suddenly become slightly less permissive. On PyPI, of course, versions always correspond to a single artifact. But if you're getting your code from Hugging Face, if you're installing it directly from source, and this is not just foundation model specific, but it is really a common point in foundation models where you're getting these artifacts, the weights and the research grade codes potentially from repositories that are not as strictly version controlled as PyPI, for instance. We fork it if you internally use the same pattern, right? Then so in your internal code base, that will also help, for instance, in managing the stability of the software supply chain, but also the stability of the contractual implications and regulatory implications like the license files. In SK-time, we have decided to use the parameter use source package where the same class allows you to use the fork in SK-time or your own fork or also a source install for repositories where the code is not available as a full Python package by the authors. So use source package equals true. Hierarchical and probabilistic forecasting, some of the foundation models do this natively, many do not, so they only do point forecasting or univariate forecasting. What we have also done is management of, so memory management. If you have 100 different time series or 1,000, then you don't want to load 1,000 copies of an already big model into memory. If you do zero-shot forecasting, it is completely sufficient if you load a single model and then apply it to all the time series. And that is also done in the background, by the way, if you use SK-time with foundation models, with hierarchical data. So for instance, different, so retail by different categories or by different shops. So the Python notebook, we are going to make it available. Eventually, you will get lifetime access to it if you sign up to our course. But Of course, we support the open source ecosystem. So eventually all the material we produce, and it's a question on the chat I'm answering, all the materials we produce will eventually be available. And of course, it needs to be interesting why you want to sign up to the course. So you get some degree of advanced access to the newest and best material if you do that. And you support the development of SK Time, this nice package, and a few others. And eventually, if you can't, if your training budget has already run out, well, it will be in some form, maybe available later. If you want it now, sign up for a course. And you also get one-to-one mentoring and nice exercise sheets that we also work on with you together for your optimal learning journey. Now, probabilistic predictions, same thing, right? If you run ensembles, you might actually construct a lot of instances, and in your native ensemble algorithms like conformal intervals, you might make 1,000 copies of your foundation model. Same story here. We manage the memory in the background to minimize the memory footprint of using a memory-intensive foundation model multiple times, and you get like lower upper confidence intervals from conformal intervals with the foundation model inside. You don't need to change any code. It works the same way as with confidence intervals or probabilistic forecasts, upper lower bands, confidence bands for, well, ordinary machine learning models, which are also often not that bad. So, or STL bootstrap prediction intervals with bootstrap and Chronos bold, same idea. So before concluding, a bit about the legal sides of foundation models are multi-component technology, which we already mentioned. There's different artifacts you have to manage on the engineering side, but the same artifacts you have to manage as well on the legal, contractual, and regulatory side. And these different artifacts may come under different licenses from different providers. The licenses can be unstable. We have already observed in the ecosystem of foundation models stealth changes to licenses of foundation models. So if you use them in production internally, it might, for instance, lead to, oh, suddenly you used a license that was not permissive. Your entire code base is tainted just because you used a set of weights which suddenly went from permissive to commercial, or well, copyleft could also happen, but all instances we've seen was the license became more commercial, and that happens if you get it from the weight repositories, or well, there's gated APIs as well. The gated APIs might be subject to terms and conditions. So if you let your code in deployment run with a gated API, then maybe there's terms and conditions that say, oh, we bill such and such by call, and if you exceed the number of calls, it's like your cell phone contract. So it's if you've ever had trouble with your cell phone contract, it's probably similar, but for corporate users. Data is another component. If you're in the European Union, the European Union AI Act may apply. And also, if you use models trained on questionable data batches or on your own data batches, you also have to consider the data angle. So status not entirely clear. We try to minimize license issues, but we cannot entirely remove them. Frozen code with version management is one good idea. And in the forks that we manage in SK Time, we also try to work with versioning, so lit version, also numbering of the code in the forks, and the forks branch of a permissive licenses. So if we have a model in there, or if we have model code in there, then we take a fork if there's a change in license, which is still permissive license. So there's also not 100% guarantee, but this is something that we try to also architecturally manage. If using weights, that's also part of the message here, inspect the licenses that come with them. So wrapping up, should you use foundation models now? So the answer obviously is not universally no, and it's not universally yes. think the answer is more subtle. They are a promising category of models. And I've heard at the same, so I've had both. So SK Time, we have the Discord, you can join it. We're a large community of practice, and it also has a lot of people who are primarily employed by companies or public sector entities. They actually deploy these models. And so we hear a lot of first-hand experiences here. And I've heard, for instance, this is actually great for my use case. I'm so surprised how well it works. And I've also heard, yeah, it's worse than the naive forecaster. So it's really hard to tell. And of course, you hear the story often. Oh, it beats everything. Forget everything you had before. Delete your code. Only use our gated API. I'm exaggerating a little bit, of course. But I think both of these scenarios are possible. So the recommendation is to do what you would always do from an empirical scientific perspective. Put it to the test. Does it actually work for you? And maybe have it as an additional tool in your, in your personal professional tool base. And also know there multiple foundation models, and they all come with pros and cons like size, accuracy, so size of the weights and the licenses of the weights. You can also try the gated models, but they will come with the cost, they will come with terms and conditions, and so on. And you have different learning tasks. They might support univariate, multivariate, it might or might not support zero-shot, few-shot, fine-tuning, and so on. So various trade-offs here, and still a zoo of models to choose from. It's not like there is certainly a single model that beats them all and you can forget everything. You've probably heard that claim if you're in the business already for more than 5 years. You've heard this kind of claim before for different types of models, I suppose. So test and benchmark on your own data, compare pros and cons, and also against the requirements for your use case. So if you want it to be ultra secure, but you have a limited memory, so then it's maybe on-prem and air-gapped and you want a small model, then maybe the edge that foundation models give you is not that big, or well, can you have all the resources you want and all the money you need, maybe you can try out everything and then see. So there's really pros and cons that you need to line up against the evidence. So how does it actually perform, and the properties of the different foundation models. In SK Time, a little bit of advertising. There's a benchmarking module, which we are currently working on. So you can, but you need not use that for backtesting your models to see how well they perform. So backtesting and forecasting is maybe the standard way to test on your historical data how well would the model have performed if you would have used it. And certainly it should beat the naive forecasters. Maybe it should also beat the very simple machine learning forecasters or statistical forecasters like dtrend and deseasonalize. I can do this everything with a few lines of code here. Complex models are often good, but not always the best. Test it on your own data. So recap. What are foundation models? We have seen that today. Pre-trained deep learning models with special capabilities like zero shot. So haven't seen any of your data before, but still can work reasonably well. Few shot, we'll give it a few additional examples, and then it might work well, or full fine tuning. So you can even adapt and continue the training process to a larger extent on your own data. It might be semi-open, fully open, or gated. Different parts of it might be open. But you have, of course, a lot of commercial providers in the gated range. Currently, the models might be hard to install, deploy, and test, also hard to integrate. There's log-in and log-out dynamics happening there, partly also commercially motivated. I've also shown you SK Time. To our knowledge, this is the only open governed community and the only major framework layer that allows you to switch these foundation models and choose them. Of course, it comes with pros and cons. So you're now using a framework if you would use it. But whether you use it or not, there is engineering aspects that you need to be aware of your own code, so handling codes, weights, and parameters under the hood. It's always good, even if you use something like skTime, to be aware what the artifacts are, what is happening under the hood. There's different weights backends as well. So Hugging Face, for instance, is not the only one. There's Kaggle Replicate and others. You can also try to train from scratch if you really want for some of the implementations. You can have these models in the cloud or locally. And vendor mini packages with stable code are available in skTime. It might also be a pattern that you might want to use locally, so not just mirrors, but really vendoring and stripping out the dependencies. We did find this in many cases. It was actually quite easy to remove a set of dependencies, which led to a really hard to install pseudo package. But many of these dependencies, strangely, you didn't even need. So if you're really going deeply on the engineering side, it's maybe also a good to know thing. With skTime, if you use it, it's the only framework really that gives you or tries to give you a neutral access to the various foundation models. Contribute if you find it useful, or join our course and also learn in more depth about this topic and others like hierarchical and probabilistic forecasting. You can also join skTime as a community. There's no cost to it. It's an open community. There's a Discord with a developer chat and a user help desk. You can also share stories about your use cases. So you're very much invited, for instance, to share what you are working on in the weekly meetups. And if you do that, by the way, you even get a discount for the course. The next cohort for the forecasting course is open to signups. It starts next week already, so we still have places available. Every time we try to add some new interesting content, also inspired by what our participants tell us, what they would find interesting. So there will be extended content this time on deep learning and foundation models, then also deployment, monitoring, MLOps, and the variant of MLOps where you also have to manage the weights and stuff for foundation models. We have also decided to move towards a flipped classroom. So we already have recorded sessions, and you will get access to recorded sessions, and we will use the time we have, for instance, for topics suggested by you, or we have exercise sheets and you work on these, and we also give you solutions for those. So in intensive use cases for cohort 3 and upcoming, we're also looking towards giving the course with a specialization topic, and soon there will be a way for you to engage. So we're going to post this on LinkedIn, where you can suggest and vote on what kind of specialization you would like for the upcoming cohorts. For cohort 2, the additional topic here is MLOps monitoring, and for instance, detecting when a model goes off rails, deployment topics, and so on. So right there on Maven, I will post the link to sign up right here. And in any case, we would be very happy to see you on the skTime Discord, maybe even in the meetup, where I can present your use case or ask questions if you want. Any questions right now? How much is the discount? So if you are a substantial contributor to skTime, and that means, so we have a governance model with elections, and a substantial contributor means 50 hours invested over the last 18-month period, then you get in for free. So core developers get in for free. You present on the meetup, so you can collect points. So meetup presentation, I think, is 25%, but you can also get up to 50% if you fix one or the other bug. So any takes on using F foundation models versus traditional forecasting models? Benchmark them, right? So anyway, you want to try traditional models first. Still, this would be my recommendation. Try the traditional models first. So statistical models, detrend, deseasonalize, and then exponential smoothing, obviously have that in the mix. Then So machine learning based models, reduction, direct reduction, recursive reduction, deployed in a global way. Also have that included. If you need probabilistic, then of course things like bootstrapping or empirical or conformal prediction intervals, parametric models perhaps. I wouldn't try foundation models first. The general recommendation is start simple, even start with the baseline. So establish on a new problem at the very first how well this naive or dummy forecaster do. And then increase complexity. And now there's different ways you can increase complexity. So either model specification complexity or things like memory and compute and throwing in more and more of either developer time or resources that are going towards the model. How easy is it to add the D-trend and D-season baseline models in the SK time benchmark? It's ultra easy. It's a few lines of code, and there's even code you can find in the forecasting notebook currently how to define those. So it's just like D-trend, multiplication, deseasonalize, multiplication, you're a forecaster. And you just stick it here in the ad estimator. Any other questions? Okay, then it was very nice to meet you. Hope to see you on the Discord and in our course starting next week. Have a nice day. Goodbye.